Hi guys, we have a question here that says, is 512 a term of the sequence 1 upon 256, 1 upon 64, 1 upon 16, and so on and so forth? So we are given the sequence, this, and we are to check whether 512 is a term of the sequence. The first thing we want to calculate is the common ratio because looking at this, it is a geometric progression. The common ratio is equal to the second term divided by the first term, which is 1 over 64 divided by 1 over 256. And that is equals to 1 over 64 times, when we change division to multiplication, we invert the divisor, times 256 all over 1. 256 divided by 64 will give us 4. So the common ratio R is 4. Now, the nth term of a geometric progression is given as A R raised to power n minus 1. We are just going to find the value of n when this term is equals to 512. So 512 is equals to 1 over 256 for the first term because a is the first term times 4 as the common ratio r raised to power n minus 1. We are going to express this in indicial form or in indices so that we can solve for the value of n. 512 is equals to 256 raised to power minus 1 in index notation times 4 raised to power n minus 1. This is the inverse law of indices. Now that we have this expression or this equation, we are going to take the left and right hand side of this equation to the same base to solve further. And we are going to express both sides of the equation in base 2. So how many times can 2 multiply itself to give us 512? The answer is 9 times. So the left hand side becomes 2 raised to the power 9 equal to, how many times would you raise 2 to the power, how many times will 2 multiply itself to give us 256? The answer is 8. So 256 is 2 to the power of 8 multiplied by this minus 1, that is at the power, times 2 raised to the power 2 to give us 4 into n minus 1. Let's open up the brackets here. So we have 2 raised to the power 9 equals to 2 raised to the power minus 8. 8 times minus 1 gives us minus 8 times 2 raised to the power 2 times n gives us 2n minus 2 times 1 gives us 2. Now they are all in the same base and we are just going to apply the multiplication law of indices. So we have 2 raised to the power 9 is equals to, the bases are the same, so we take the base and add the powers. So we have minus 8 plus 2n minus 2. Since the bases are the same, it means the power will equally be the same. But let's solve this further. 2 raised to the power 9 is equals to 2 raised to the power minus 8 minus 2 gives us minus 10 plus 2n. Like I said earlier, the powers will be equal because the bases are equal. So the exponents are equal, so we can solve for the value of n from here. 9 plus 10, if minus 10 crosses the equation sign, is equals to 2n. So that 2n is equals to 19. If we divide both sides by 2, the value of n will be equal to 9.5. Since 9.5 is not an integer, it means that 512 is not a term in this sequence. For a number to be a term in a sequence, that nth term must be an integer, but 9.5 is not an integer. So we can conclude to say, since n is not an integer, then 512 is not a term in the sequence. I hope you enjoyed this video. Please try this. Which term of the GP 2, 2 power root 2, 4, and so on and so forth is 128? Please put your answer in the comment section, and thank you very much for watching. Don't forget to like, share, and comment on our video. And if you are seeing us for the first time, please follow our page for more. Bye bye.